Welcome to Neuroabilities, an exciting program to explore the potential of neurotechnologies and brain-computer interfaces for a person with disabilities, but also to analyze all the implications and the potential issues that those may raise.
Pleasure to be here.
Thank you. So my first question is about this terribly interesting technology that you've been developing for many years to develop navigation tools for people who are partially or totally blind. Most recently, it looks like after developing GPS tools, you are on something called the final 50 feet problem. So can you tell us a little bit about why you can now solve the last 50 feet problem and what advances in technology has led you to this conclusion?
Well, technology keeps evolving, and I think we're not 100% of the way there, which is a good thing because it's always fun if there's still a bit of a challenge ahead of us, if there's still something to pioneer. But certainly things have evolved tremendously. I think back, almost 200 years ago, James Holman, the explorer, the blind explorer, was doing a lot of amazing things with a lot fewer tools than we have now. But the motivation, the need for independence is still the same. I've always said that visual independence, visual acuity is not really the measure of one's blindness, it's how well you get around. And of course, my mother instilled this in me from an early age, and I've been exploring it and finding out better ways to get around ever since. And in the early days of GPS, the accuracy was 100 meters. And I still think that was better than nothing, because if you had to depend 100% on directions from a sighted person, it was maybe not even as accurate as 100 meters. I've always said, let's ask 5 people for directions and then average the answers. Now with technology, you have alternatives to just asking a sighted person for help, and that will get us to the building. And now there's technologies that are helping to refine, in some situations, getting actually to the doorway, but that's not 100% reliable. We still have to depend on our individual skills and techniques, and then think of the tools that we have, the technologies that we have, as a way of augmenting those personal tools and techniques.
So just to switch gears a little bit, even though I'd like to talk at length about this, about 20 years ago, you took a chance, and I guess it's one of the hallmarks of your career that you are an explorer. It's interesting that you mentioned James Holman, because it seems like your mother's advice took you out into the world to explore. But you took a chance on advances in medical research and had some surgery, stem cell and corneal transplant. And while these procedures are not technically considered neurotechnology, your vision has been studied extensively and by neuroscientists. And I wonder if you could talk a little bit about what's the connection.
Well, when I had the option for some surgeries that would give me some vision, I seriously considered not going ahead with it because of many different reasons. The list to not have the operations were certainly longer than the list to have them. Curiosity was really the factor that made me go ahead, because I wondered, well, what would it be like to have some vision? And as you study the different people that have had restored vision after long-term blindness, most of the cases end up poorly. And that's because the expectation is that if you get restored vision, all of a sudden you're going to be able to drive and read. And that's just not the case. It's a lot of interim places where vision just doesn't work that way. It's not that black and white. And I didn't know that either. And so when I started this journey in the year 2000, I was just curious. And once Ione Fine, Dr. Ione Fine, and Don McLeod from UC San Diego at the time brought me in and started explaining to me that, in fact, vision is very complicated, and you are an articulate baby. Otherwise, we're normally studying vision from human beings who can't talk, and all of a sudden you can tell us what you're seeing and not seeing. And it's been a 20-year journey since then. I'm still going into the lab with Ione Fine and Feng Chang now at University of Nevada, Reno. Back in the day, Brian Wandel at Stanford, Alex Wade, a lot of different individuals at Caltech, different universities, even over in Europe, the late Dr. Richard Gregory and a lot of Europeans were involved in asking the questions that you're posing today to learn more about the whole vision process. And so I've had this wonderful front row seat of learning about vision from the standpoint of these neuroscientists.
Was there any post-surgical therapy or training?
There really was no formal new vision rehabilitation, and hopefully that has improved over 20 years. If there's more cases of people getting some vision, they would have the benefit of professionals that could talk to them about these issues of should you have the surgery, and if you do, this is how it evolves, because every situation is going to be personal to that particular person's situation and visual acuity. So it really would have to be customized rehabilitation, which is the case in a lot of different therapies. I didn't have any formal training. It was really a result of me experimenting, and I've been a beta tester of software, and so why not experiment with my own body in the same way and see, well, let's see if this works or that works, and then reporting the results. I've loved being part of that process, guided by the vision scientists, and that's really brought me to the current situation where I don't think about the vision so much, but I still do like exploring it if there's some new approach.